Hello everyone, welcome to this video. In this video, we shall be looking at another question from IIT-JAM 2022. Right, this is a numerical answer type question and it is of 2 marks. So here, let's first see what is this question here, and then we'll be talking about its concept and solution technique. Right, so here they are saying if we are given some function, with this is a function in 2 variables x and y. The function is given to be x square plus 2y square minus x. So this is our given function. Now you are given 2 kind of domains. One is that of a circle, another one is that of an ellipse. Right, these 2 domains are given to us by the name D and E. Then they are saying whichever is the number of the points at which we have absolute maxima, they lie in the set D max. The points where this function f has absolute minima would lie in D min. And similarly for this region E, the points for which the function's value is maximum, that means we are getting absolute maximum, would lie in E max, and in E mi we have absolute minimum in the region E. Right, so they are saying whatever is the number of points, when you take the union of all of them, you again would have some set. So they are asking what is the number of elements present in this particular set. Right, so this is the question and we are required to solve this question here. So let's get started. First of all, here if you remember, whenever we are calculating the absolute maximum and minimum for a certain function, what we are doing, we are calculating the critical values. Right, so first of all, for the solution, we have the function f of xy as equal to x square plus 2y square minus x. So this is our given function. Right, so here for the critical values, what we will do, we'll first calculate the critical values of f. So let's see what are the critical values. For that, we'll firstly differentiate this with respect to x partially, keeping y as constant. So it would be 2x minus 1, and then we'll be differentiating it with respect to y partially, keeping x as constant. So it would be 4y. So I hope you know how to perform this partial differentiation. Next, in order to have this the critical points, will substitute both of them as equal to 0. So this would give us 2x minus 1 is equal to 0. So that means x is equal to 1 by 2, and 4y is equal to 0 would give us y is equal to 0. So from here, what is the point that we are having? So we have the critical point is 1 by 2 comma 0, x and y, which lie inside the given domain D and E. Now once you have this critical value, what do we do next? We calculate our function's value at that point. So what would be f of 1 by 2 comma 0? So f of 1 by 2 comma 0. So we'll be substituting x is equal to 1 by 2 and y is equal to 0 in the given function. So what was our given function? X square plus 2y square minus x. So it would be 1 by 2. So let me write down here. It would be 1 by 2 square, right, plus 2 times of y square, that is 0 square minus x. So when you solve this, let's see what we have. 1 by 4 plus 0 minus 1 by 2. So the answer is minus 1 by 4. So this is the value of the function. So let me mark this as f of 1 by 2 0, its value is equal to minus 1 by 4. So this is one of the value. Now in order to determine what values do we have at the boundaries. So in order to have local maxima and minima, we are required to see the function's value at the boundary as well as inside of the region. So what is the function's value at the boundary of the region D and E? So this is the next question that we have to see. Right, for that, for region D, so let's discuss both of the regions one by one, right? So we have x square plus y square less than equal to 1. So obviously, you know what is this? This is a disk having radius 1, right? So we have it like this. Right, so this point is 1, this point is 1, this is -1, and this is -1. So this is our disk, right? This point is 0. Now for this disk, and we also have the boundary included here, so this is a region D, right? Okay, so here for this particular boundary here, and for this particular region D here, what do we require? In whenever we have some rectangle or whenever we have some square, what do? We take the boundary points also in addition to the critical points whenever we are checking the absolute maximum or the minimum value. But in this case, which values would you consider for the boundary? We do not know yet. So for that, what do? We create another function. So from here, for the boundary, what do? What is the boundary here? X square plus y square is equal to 1. So this equality here represents that we are on the boundary, the circumference of this circle, right? For this boundary we have this thing. From here we just calculate the value of y square. It is 1 minus x square. Now we'll substitute this value in f of x, y. So what do we have? We would have another function which we say call by g of x. So that would be nothing but x. In place of y, we are now writing the function x. So what was your function f? It was x square plus 2y square minus x, right? So here, in place of y square, we will be writing 1 minus x square as above, minus x as such. So this was the function where instead of this y square, we are now writing 1 minus x square. So you can solve this, x square plus 2 minus 2x square minus x. So that would be equal to 2 minus x square minus x. So this is your function g of x. Now what do we wanted to do here? Now we have obtained our function from 2 variables to 1 variable. So we will now be calculating the critical points for this function g of x, when what is the maximum range for x? If you see, your x varies from here to here only, right? So what is the limits here? Your x varies from -1 to 1 only, right? So for this particular region, what is the critical point? For that, what do? We differentiate this function with respect to x, and this is a ordinary differentiation, complete differentiation. So this is minus 2x minus 1. So we'll be substituting this equal to 0, so that we have minus 2x minus 1 is equal to 0. From here, what do you have? You have the value of x as equal to minus 1 by 2, right? So this is the value of your function x is equal to minus 1 by 2. So this is the value that you obtain. Now what you wanted to do for this particular critical point, what is the value of y, right? So here now we have 3 values of x. One value is minus 1 by 2, one value is minus 1, and one value is 1, right? Because they are the extreme values, and this is the critical value for this particular function. So we will see what is the function's value, what is f of x comma y at these points. X is equal to 1, x is equal to minus 1, and x is equal to minus 1 by 2. So this is what we will be seeing next. So first of all, let me write down when your x is equal to 1, what is the value of y? So we will be calculating this value using this expression, because that is what is our boundary for the region D. So here we wanted to calculate y square. Our y square is 1 minus x square. What is the value of x here? That is 1. Right? So you have 1 minus 1 square, that is 0 only. So you have y as equal to 0. So therefore, what is your point? Your point here is equal to the value of x is 1, the value of y is 0. So you wanted to calculate the function's value at this particular point. So what was your function? It was x square minus 2y square. Let's check. x square plus 2y square minus x. So you have x square, that is 1 square, plus 2 into y square, that is 0 square, minus x. So you have 1 plus 0 minus 1, which is again 0, right? So the so you have this thing, that the function's value at the point 1 0 is 0, right? Next we'll be checking when x is equal to minus 1. When x is equal to minus 1, what is the value of y? Again we will be using the expression x square plus y square is equal to 1. From here y square is 1 minus x square, so that will give you y is equal to 1 minus, what is the value of x here? Minus 1 square. So you have 1 minus 1, that is again 0. So here what do you have as a point? So we'll be calculating the function's value when x is minus 1, y is 0, as we have just calculated above, right? So here it would be the function, it was x square plus 2y square minus x. So our function here would be minus 1 square plus 2 into 0 square minus of minus 1, right? So this is what we have. So let's compute 1 plus 0 plus 1. So this is equal to 2. So the next value that we have with us is this one. And for the last value, when x is equal to minus 1 by 2, right? And x is equal to minus 1 by 2. So what is the function's value? What is y here? First of all, you have x square plus y square is equal to 1. So from here you have y square is equal to 1 minus x square, and from here you have y square is equal to 1 minus, the value of x is minus 1 by 2 square. So you have 1 minus 1 by 4, that is 3 by 4. So what is the value of y here? It is square root 3 by 2 plus minus. So you have two values here. So you will be having, you have to calculate the function's value when x is minus 1 by 2. So when x is minus 1 by 2 and when y is root 3 by 2 positive, and you will be calculating the function's value when x is minus 1 by 2 and y is minus root 3 by 2, right? So let's calculate the values. If we have x square plus 2 into y square minus of x, right? So it is 1 by 4 plus 2 times of 3 by 4, right? And plus 1 by 2. So when you solve this thing, what is the value here? Finally it is 9 by 4, right? And when you solve this one, so it is minus 1 by 2 square plus 2 times of minus root 3 by 2 square minus of the value of x, that is this one. So you have 1 by 4 and then plus 2 into 3 by 4, right? Plus 1 by 2. So that is the same expression. Again you have the same value as 9 by 4, right? So you have two values here as these ones. So now we wanted to compare the absolute maximum value in the, it occurs at which of the following points, and we wanted to check what is the absolute minimum of the given function f in D, right? So this would be nothing but your D max and this would be nothing but your D min. So let's check and compare the values here. For the absolute maximum, let's see what do we wanted to compare here. So let me highlight the points, this point, this point, this point and this point, right? So these are the points, and one more, this one point. So you have the value minus 1 by 4 here, the function's value 0 here, the function's value 2 here, 9 by 4 here, 9 by 4 here. So obviously these two are the maximum values, 9 by 4 and 9 by 4, right? So that means the maximum function's value is obtained at the point, which one? So we have 2 points here. First one is this one, minus 1 by 2 and root 3 by 2, and the second point here is minus 1 by 2 and minus root 3 by 2. So we have two values here. And for the minimum value, what is the minimum value? These are the positive values, 2, 9 by 4, 9 by 4, and this value is 0, and one more value, it is minus 1 by 4. So obviously this is the minimum value here, right, for D. So that means what is the point? 1 by 2 comma 0. So we have our set as 1 by 2 comma 0. So we are done with one region for the question. Now coming to another region for, so let's compute that also. For region E, what is that region? It is given to be x square by 4 plus y square by 9 less than equal to 1. So what is this? This is the given ellipse region, right? So here for the boundary we have the equality sign. For boundary we will be taking this x square by 4 plus y square by 9 is equal to 1. So first of all, let's see this region here, right? So here we have our x's, right? Now here if you substitute x as 0, so what do you have? Y square by 9 is equal to 1. So the maximum limits for y, they are plus minus 3. So that means y here would lie up to these places, right? And when you substitute y is equal to 0, you have x square by 4 is equal to 1. So you have x is equal to plus minus 2. So that means the maximum values here are plus 2 and minus 2 for this one. So let's draw this region here, right? So you would have something like this. So this is your ellipse and this is the region E. This is the region E, right? This is the ellipse, right? So in this region we wanted to see what is the minimum and maximum value for the given function. So here for this region we'll again be converting the given function f of xy into some another function, say h of x, right? A function in one variable. So let's do that. So for that we'll be taking the boundary for E, right? So from here you have x square by 4 plus y square by 9 is equal to 1. So from here what is the value of y square? That is 1 minus x square by 4. So we'll be substituting this. So we'll be substituting this value in the given function f of xy. So what do we have? Let's call that function as h of x. So that would be f of x and x. So that would be your function was x square plus 2 into y square. Now y square is 1 minus x square by 4 minus of x. So you have x square plus 2 minus x square by 2 minus of x. So what is this? So when you compute and solve this, this is x square, right, x square by 2, right, plus 2 minus x. So this is your function h of x. Now we wanted to solve and compute the critical points. We wanted to compute the critical points for this function h of x. I'm sorry, we also had this value 9 here, right? So 9 here. So here also we should write 9. So what do we have here? It is 18, right? And it is equal to 9 x square by 2. So when you solve this, you have minus 7 x square by 2 plus 18, right, minus x. So this is your function h of x. Now in order to determine the critical points for this, we'll first be calculating the derivative for this function. So it is minus 14x by 2, right? So or you could simply write minus 7x minus 1, that is equal to 0. So when you substitute this as equal to 0, what do you have? You have minus 7x minus 1 is equal to 0, or the value of x is minus 1 by 7. So this is the point which is the critical point for this particular region. And here what is the range for x? If you see what is the range for x, your x here varies from the point minus 2 and plus 2, right? That is the maximum range for this function. So here you will check. So here we will check the function's value. We will check the function's value at x is equal to minus 1 by 7, x is equal to 2 and x is equal to minus 2. Why? Because as this is the maximum limit. So this is the maximum limit of x in the region E, right? So let's first of all check when x is equal to 2. When x is 2, what is the value of y? We have y square is equal to 9, 1 minus x square by 4. This was the given region. So you have y square is equal to 9, 1 minus, what is x? X is 2. So 2 square by 4. So this value is 0 only. So you have the value of y as 0. So your function would be 2 comma 0. So your function was x square, that is 2 square minus 2 times of y square plus 2 times of y square, that is 0 square minus of x. So you have 4 plus 0 minus 2. So this value is 2. So let's mark this value by the pink color, right? So next calculate for another point when x is equal to minus 2. Let's calculate what is the value of y. So it is 9, 1 minus x square by 4. So you have the value of y square as equal to 9, 1 minus 2 square by 4. So when you compute, this is also equal to 0. So the function's value here is calculated at the point minus 2 comma 0, right? So what is this? So it is equal to x square. X square is minus 2 square plus 2 times of y square, that is 0 square minus x. Minus x is minus 2. So you have 4 plus 0 plus 2. So this value is 6. So let's also mark this as. So we'll be comparing these points finally. And lastly, we have to compute when x is equal to the critical point, which is equal to minus 1 by 7. So when x is equal to minus 1 by 7, let's compute our y. So we have 9, 1 minus x square by 4. So you have 9, 1 minus the value of x is minus 1 by 7 square divided by 4. So when you compute this value here, so what do you have as y? Y is equal to plus minus of 3 by 14 square root of 195. So this is somewhat lengthy calculation, but still we are able to get this value. Okay, so here we have two values of y. So that this implies y is equal to these two values, right? So we'll be calculating the function's value at these 2 points. So let's do that. So the function's value calculated at minus 1 by 7 and the positive value 3 by 14 of square root of 195. This is equal to, so it is my x square plus 2 times of y square, that is 3 by 14 square root 195 square minus of x, right? So when you solve this, finally what do you have as the value? Its value came out to be 18 1 by 14. You can check this value, right? So let me mark this here. And for the negative value of y, so when you compute f of minus 1 by 7 with the negative value minus 3 by 14 of square root 195, this is equal to x square plus 2 times of y square minus of x. What is x? Minus 1 by 7. So this is exactly the same value, that is 18 1 by 4 when you compute this one. So we'll be comparing this value, the function's value here, here, and one more value. Which one? The critical value of f, which we computed firstly, right? So this value in the very starting, right? So we'll be computing all these values here for calculating Emax and Emin, right? So let me write down what would be your Emax. So it will contain all those points where we would have the maximum value. So obviously you see this 18 1 by 4 and 18 1 by 14, right? This is the maximum value out of 6, 2 and minus 1 by 4, right? So we have 2 points. One point is this one, minus 1 by 7 and 3 by 14 square root 195, and another point is minus 1 by 7, 3 by 14 square root 195, right? So, and what is the value of E min? Obviously, out of 18 1 by 4, 18 1 by 14, 18 by 1 by 14, 6, 2 and minus 1 by 4. This point minus 1 by 4 is the minimum value. So here the point that we'll be taking is this one, 1 by 2 and 0. So E min would contain the point 1 by 2 comma 0. So it would contain the point 1 by 2 comma 0. So what is the union of the all of these? So E max, E min, union with D max and D min. So let's list all the points here. First of all, E max contains these 2 points, 1 by 7 with 3 by 14 square root 195. E min contain minus 1 by 7, 3 by 14 square root 195, right? And E min contain 1 by 2 with 0. Then D max and D min, let's see these two also. This point is already noted, right? So we'll be skipping this one because we are taking the union. So the other 2 points are minus 1 by 2 and square root 3 by 2, minus 1 by 2 and square root 3 by 2, and minus 1 by 2 and minus square root 3 by 2. So we are required the number of elements present here, number of present elements in the above set. How many of them are there? 5. They are equal to, the number is equal to 5. So we have 1, 2, 3, 4 and 5 members here for this particular set. So the answer here is 5. So I hope you understood this question. So for the purpose of understanding and making you understand this, I have explained it thoroughly. For the purpose of paper, you could speed up the process. Once you know the process and the method, you could do it fast, right? And have the answer with you. Well, that is it for this video. Thank you for watching.